Hello all. So after creating the parts, we'll go to the properties and assign the property, create the materials first. So we'll go with the macro manager again here. We'll create a new macro in the working directory and click on continue, and we'll dismiss this dialog. We'll create a property, we'll call it rock. It will be fractured rock, ROCK. Yeah, so it will be fractured rock, not exactly the rock which we consider as rock mass. So I have the density of rock as 2400 kilogram per meter cube, so you should have the units very much same, kilogram, meter and newton, and like that. So the Young's modulus I have is 100 megapascal, so E6 Poisson ratio is 0.35. Then I have the C and 5 parameters. So we'll go with more column plasticity. Here you can create a tension cutoff, or it doesn't matter, but basically friction angle of 45 degree, and again minus 30 will be 15, and cohesion I am assuming here as 10,000 or 10 kPa, and tension cutoff will be accordingly I guess will keep that some random value. So just for the sake of recording this macro, we did that. And if you are following my previous tutorial, so I have you can see what I am going to do here is that I am going to open this macro as well as my old file, which is sketch.all. So I am first going to look into this macro which we have created. So this is the material model creation. So we name the material model rock, and we provide density, elasticity, more column plasticity using hardening, which is cohesion, and 10 tension cutoff. So we have already done this in our previous tutorial. So what we are going to do is that we are going to create our properties using these files only. So I'm just going to copy these lines from my previous file, and I'm going to paste it in this section. So here I will call rock and soil only. Maybe instead of rock I'll just call fractured rock, so that it will be better. And these three materials are not required, so only two materials. So we have the density of fractured rock is 2400, soil is 2000. So I'll remove this other three rows. Fractured rock I am taking as 100, so 100 here, and for soil I am taking as 30 megapascal. So I'll remove other lines. Poisson's ratio is 0.35 and 45. So these are the Poisson's ratio. Now regarding friction angle, you can just put as 45, and for the soil I am taking as 20. So there is a bit of trouble, but yeah, you can see here what I am going to do. And yeah, basically we can just remove, because both these materials are more column materials, so we don't require these lines. So we can just cut this and paste it here. 5 will be 4520, C will be 1000, 10,000 and 20,000. That's what I am assuming here. These are C5, and we can also get our tension cutoff T. So I am assuming a tension cutoff of I guess it will be tension cutoff is basically based on phi, so we don't need to take any tension cutoff. But what we can do is that instead of phi minus 30, we can put here as a dilation angle. So dilation I, so we can put dilation, we call it dil. Yeah, so dilation for 45 will be 15, and dilation for 20 degree will be 0.1. so a minimum value we can assume, although ABAQUS automatically assumes this value. So if you are following, we are not assuming damping here, so we'll remove this line. So yeah, we have the name of the materials, then we have density, then we have elasticity, then we have molecular plasticity, which will assign phi and dilation angle, then it will assign C. So again here we have to put Ci because there are two C's, and yeah, Ci, and math tan math radian phi I, yeah, that will do the job. And yeah, we are going to save it and maybe just clean the slate and run the script which we have us here. Yeah, so there is an error. Oh, material MC not defined. So yeah, there are these issues from the previous code. We have to remove the material MC. I guess there are nothing else. Now we'll save it and run it. So in the real time you will get this type of error. Yeah, math is not defined. Yeah, so sorry, I have to do a bit of we have to import math as well. So if you are not familiar with, you can just directly jump onto the tutorial. Without this part I will be doing both of them. So anyway, you need not to worry. So we'll run the script and see. Now the script has been run, two materials have been created. Now we have to move on to the part module. So we'll create the part. So we'll again copy the part module creation from here. And if you have been following this part module creation, is pretty simple. We only need two parts. So we'll create our part before the assignment of property. So in the model one, we'll create instead of blast BLT part, we'll call ROCK part, and the sketch will be no, actually not rock or soil. We'll just call them as top part and TOP, and we'll assume a depth of 1 meter, maybe 2 meter, maybe 1 meter, because we don't want our simulations to run beyond specific time limit. So we'll remove this line and we'll just copy this line and paste it here. So we have three sketches. Now we'll create three parts: top, middle, okay, control C, middle, and bottom. So these are the three sketches I am getting here: bottom sketch, middle sketch, and top sketch. Yeah. So top, middle, bottom. Top, here I will do middle, and bottom. So these are the parts creation. We don't have any parts with us, so I will again clean the slate and I will run the script again and to show you. So we have three parts now, you can see. Now what we have to do is that we have to just create the sections. So we'll go deeper into our previous file and we'll create sections using these files, and then we assign the sections and also make the assembly using these lines. So basically there is not much to do. We can just copy paste what we have done previously. Yeah, so like that, instead of sections, we can create only two sections. Basically we now require only two sections. One is rock section and other is soil section. Okay, so before running these lines, I'm going to comment these lines because we require deformable body. One part should be Eulerian part. So we have to do some setting changes. So here we have created three parts. So let's just go to the part module and check out this top part should be Eulerian part. So we can edit the part and we can change it to Eulerian, and we'll not do that right now. We'll go to the macro manager and we'll record another macro. We'll click on continue and we'll go to edit and create this part as Eulerian and just stop recording so that we'll see what changes are required to be done. Yeah, here we have to just change the type as Eulerian. So I'm going to do that to the top part. Yeah, So type Eulerian for the top. Now we are going to save this. Now we can do and go ahead with the material section creation. So one is rock section, one is soil section. There is no other section basically, so I'm going to remove other three sections. And yeah, homogeneous section, material section, and material names. So we have two materials, and yeah, based on that we can create a materials section. So yeah, yeah, code basically is same, so we don't need to do a lot. So I'm going to comment out this to check whether this is the section creation is working fine or not. I will again go to dismiss this. What I'll do is that I will also delete the macro here. Yeah, these are deleted, so we'll go to macro manager again. Yeah, we'll see there is nothing. Now we'll again clean the slate and run the script. And yeah, we can see that we have parts and we have sections. We have two sections with us, rock and soil section. Now we'll assign this rock and soil section to our parts. So we have three parts here, and this is top, middle, and bottom. So I'm just going to uncomment this, and I'm going to call this as top part, middle, and bottom part. And I will remove the other lines, basically it doesn't require. So we have parts, we can get all the region, and we have section assignment as material section I. So basically what this line is doing is that it is assigning different we only have three parts, but we have two sections, so there might be a problem. So we'll not run our code here because it is not required. So I'm just going to comment this line out. I'm going to remove this loop, and I'm going to shift them to a tab below, and instead of parts I'm just going to call this as top part, and the top part will be made up of I guess soil. So maybe I guess this is the time where I finish this specific tutorial. So what we have done in this specific tutorial is that we have created sections, and we have created Eulerian part, one Eulerian part. So in the next tutorial I am going to assign this sections to these parts, and will most probably try to create an assembly and start the analysis. So thank you.